Let's face it, modern infrastructure is failing. For decades we have known about climate change, yet what have we done to change? What have our governments done to help? In this video, we will be exploring the topic of sustainable infrastructure and why it's the future of civilization. Our goal is to advocate for sustainability around the world and spread awareness about it and how it improves our quality of life.
We all say we need to change our habits, our lifestyles, and our environments in order to become more sustainable. But instead of tweaking the minor issues that would only ever mitigate the outcome, why don't we solve the problem starting from the very foundations of our modern civilization? Buildings, services, and infrastructure. This is the starting point to sustainable advancement, the very beginning of a new era. Sustainable infrastructure isn't just the same old solar panels we stick to a building. No, it's way more than that. It drills into our day-to-day problems, from solid waste management, renewable energy sources, all the way to turning food waste into biogas for energy and electricity. Sustainable infrastructure goes into the very core of our modern systems and tries to make them more efficient, eco-friendly, and environmentally sustainable.
Sustainable infrastructure has a variety of goals, ranging from improving the lives of people around the world to reducing extreme poverty, becoming more eco-friendly, and giving greater access to education to all parts of the world. However, the main goal of sustainable infrastructure is to make sure that infrastructure meets our needs in a sustainable fashion, without giving compromise to future generations to meet those same needs.
Sustainable infrastructure achieves these goals by streamlining modern infrastructure and making it carbon neutral, environmentally friendly, enjoyable for people, and more. There are a variety of methods to do this, and that is why we will be taking a look at Hong Kong, where a variety of sustainable developments are being made to further our understanding of sustainable development and infrastructure. In Hong Kong, the government has designed some special sustainable parks that could lead us closer to a more green type of urban planning, with sustainable infrastructure for residencies and workspaces. These government-funded parks include O Park, Zero Carbon Park, Eco Park, We Park, and T Park.
Parks mentioned all have something in common. They include major green design innovations you can be seen in the aesthetics of the builds, the ability to generate their own electricity, the systems of which they use to reduce their carbon footprint, and even the construction process of the parks themselves have been thought through to make sure they are sustainable. Let's take a look at our first example, O Park. They combust and use 300 tons of food waste per day. They are Hong Kong's first sustainable park to utilize anaerobic digestion in order to create electricity. Anaerobic digestion is a process which microorganisms such as bacteria break down food waste and release biogas into the air. It then goes through a process called desulfurization, where they remove all sulfur from the gas itself. Electricity is then generated through the combusting of a filtered biogas, which is for self-sustaining operation, and surplus energy is exported to the power grid.
Now let's take a look at We Park. We stands for Waste Electrical and Electronic Equipment. We Park is a government-funded park that has the aim of implementing the WPRS to promote the proper recycling of regulated we, turning them into resources and thereby promoting a circular economy. They do this by collecting tons of electronic waste every day. These include scanners, printers, computers, air conditioners, TVs, and washing machines. First, they unload the waste at the storage site. Next, they organize the waste into different categories. The sorted waste is then weighed on a scale to register the new generated waste. Finally, the waste is transported into 4 lines of processing.
Line 1. Refrigerator processing. The refrigerators are crushed and dismantled on conveyor belts in an inert atmosphere whereby potentially flammable insulation will be extracted safely and metal and plastic components will be separated and turned into secondary raw materials. Line 2. Air conditioner dismantling. Refrigerants such as CFC or HFC are extracted from air conditioners for proper disposal. The air conditioners are then transferred to Line 3 for further material separation.
Line 4. CRT from TV monitors or screens are dismantled by hand using hot wire in order to separate the lead-containing funnel gas and to extract the fluorescent powder for proper disposal. Aside from that, flat screens are cut open automatically using a robot arm, and the mercury containing fluorescent lamps are removed for proper disposal. The remaining parts are transferred to Line 3 for further dismantling. Line 3 is very special. Instead of being in charge of a certain product, it is responsible for dismantling computers, washing machines, air conditioners, as well as TVs and monitors. Then, they shred and sort it into secondary materials such as steel, copper, aluminium, and plastics. These can be used for parts to make new electrical products. Just in March 2021, they have recovered 299,000 kilograms of copper and 674,000 kilograms of iron.
Last but not least, there is Zero Carbon Park. Here, they use biodiesel from another facility called EcoPark to generate energy with a biodiesel tri-generator. This generator produces 3 key outputs: electricity, hot water, and exhaust heat. The heat gets sent up through chimneys and is let out into the atmosphere. This is alright because there isn't anything in the heat that can pollute the atmosphere itself. At the same time, the electricity generated is sent to the distribution panel that powers a zero-carbon building, air handling units, electric chillers, and other nifty machines that help make the ZCP a sustainable carbon-neutral park. Finally, the hot water gets sent to an absorption chiller and a desiccant dehumidifier, both of which help lower the temperatures of the inside of the building. The absorption chiller uses the evaporation and condensation of water to produce chilled water, and is an energy-efficient alternative to the usual electric chillers found in things like air conditioners or modern-day buildings. The chilled water then goes to the desiccant dehumidifier, which dehumidifies the air and sends it to the air handling units. This means that within the zero-carbon building, the air will always be at a much lower humidity than the outside. This helps with the cooling process of the building, as hot air normally holds more moisture than cold air, and thus when the air is dehumidified, it becomes easier to cool. The energy generated by the biodiesel tri-generator alone is not enough to power the ZCB, so other energy sources are needed to help with keeping the building powered.
This is where solar panels come into play. The ZCP has 3 different types of solar panels. There's a normal type of polycrystalline solar panel which can be found in all sorts of commercial spaces and buildings which you're all familiar with. The second type is called the Air Improvement Photovoltaic, or AIPV for short. The AIPV is made of environmentally friendly materials, 90% of which can be recycled, and by using new nanofilm technology, it can generate electricity and purify the air at the same time by decomposing pollutants in the air. The AIPV can also be made into a variety of different shapes, sizes, and colors. Thus, they can be used in a variety of infrastructure designs without obstructing any aesthetics. The last type of solar panel is called the Building Integrated Photovoltaics, which is used in the viewing platform of the ZCB. The BIPV is also being increasingly incorporated into the construction projects around the world. The power generated by both the solar panels and the biodiesel tri-generator is able to supply the ZCP with sufficient power. But when a building needs extra power, it will be pulled from the grid. This process produces a carbon footprint, and in order to neutralize the carbon footprint, the ZCP will put any excess energy that is produced back into the grid, but also saving some in Tesla batteries.
But this is just what Hong Kong has done to investigate and research different sustainable technologies, and it is good to see that other countries are trying to implement sustainable infrastructure into their own builds and infrastructure as well. For example, there is the Malmo Live, which incorporates sustainable features such as solar panels and geothermal energy. However, it goes without saying that many other developed countries have much more resources and money than Hong Kong, and if Hong Kong can invest their time, resources, people, and money into creating sustainable parks and facilities such as the aforementioned ones in this video, we would be solving the root issues of infrastructure globally instead of just locally.
As people, it is essential for us to advocate, to make our ideas known to the rest of the world. As people, it is important for us to raise awareness for what we believe in, to take action and make a difference with the limited resources we have. As people, we should believe in sustainable development and sustainable infrastructure. We should create a new world where if we look around, there would be households powered not by fossil fuels, but by renewable energy such as solar power, biomass, or geothermal energy. Thank you for watching, and we hope that you can also help raise awareness about sustainability.